For over 30 years, the Hubble Space Telescope gave us breathtaking views of galaxies, nebulae, and the birthplaces of stars. But now, a new eye has opened on the cosmos, and what it sees is rewriting everything we thought we knew. This is the story of the James Webb Space Telescope versus Hubble, and how Webb is revealing the universe's very first light. For decades, we thought we knew what the universe looked like. One telescope, Hubble, changed that. Launched in 1990, the Hubble Space Telescope transformed astronomy. Before Hubble, space looked blurry, uncertain. Even the best telescopes on Earth had to peer through our planet's thick, shimmering atmosphere. Astronomers dreamed of putting a telescope in space, above the distortion, to get a crystal-clear view. Launched into orbit about 340 miles above the Earth, Hubble opened a clear window to the cosmos. It transformed astronomy into a source of public wonder. Hubble's mission was to see invisible light, the same spectrum our eyes can see, plus some ultraviolet and near-infrared. From its vantage point, it delivered images of unprecedented sharpness and depth. Suddenly, smudges of light resolved into magnificent spirals, arms glittering with billions of stars. It showed us stars exploding, spreading their elements across space. Hauntingly beautiful planetary nebulae, the final glowing breaths of sun-like stars. Then came the Hubble Deep Field, a tiny, seemingly empty patch of sky, about the size of a grain of sand held at arm's length, filled with thousands of galaxies. Some were spirals like our own, others were strange, irregular shapes from the distant past. Hubble showed us a cosmic ocean teeming with island galaxies. For more than 3 decades, Hubble has been our most reliable guide. It helped measure the age of the cosmos and confirm dark energy. It photographed the atmospheres of planets in our own solar system, and gave us first glimpses of worlds orbiting other stars. Hubble brought the cosmos into our homes and into our imaginations. Hubble is a masterpiece, but like any tool, it has its limitations. It sees primarily invisible light, with some ultraviolet and near-infrared. That means it can miss a huge part of the cosmic story. Imagine trying to understand a forest by only looking during the day. You'd miss all the nocturnal life. Cosmic dust acts like a thick fog to visible light, hiding stellar nurseries. Hubble shows glowing surfaces like the pillars of creation, but not the action deep inside. And as the universe expands, light stretches, redshift, pushing the earliest galaxies into the infrared. Hubble can't see that light. It's like a radio not tuned to the right frequency. Infrared is essentially heat radiation, the universe's night vision, revealing cool, distant and dust-shrouded objects. To glimpse the universe's first stars and galaxies, we must see in infrared. In 2021, after decades of planning, the James Webb Space Telescope launched, the most powerful space telescope ever built. Its golden mirrors span 21 feet, with 18 gold-coated beryllium segments and a sunshield the size of a tennis court. Unlike Hubble, Webb orbits 1 million miles from Earth at L2. Its 5-layer shield keeps instruments near 233 degrees south, blocking infrared glow from Sun, Earth, and Moon. More than twice Hubble's diameter, it's a bigger bucket for catching light. That lets Webb see much fainter, more distant objects, back toward the dawn of time. Webb's infrared instruments take stunning images and split light for spectroscopy. From spectra, scientists read chemistry, temperature, and motion across the cosmos. Webb is a time machine, a dust piercer, and a chemical analyzer. Nothing shows Webb's power like seeing what Hubble made famous, side by side. Not which is better, but how different ways of seeing complete the picture. Hubble's iconic pillars show majestic dark towers of dust and gas. Webb's infrared view turns dust translucent, filling the scene with countless stars. Bright red, young stars wrapped in dusty cocoons, once invisible, now revealed. We've gone from the outside to inside the delivery room. Hubble shows elegant shapes, starlight and long tidal tails, a snapshot of galactic chaos. Webb reveals massive shockwaves, the glow of superheated gas and collision-triggered starbursts. When Webb looked at the ultra-deep field, it went deeper, faster. Hubble saw faint red smudges. Webb revealed well-defined galaxies, some from only a few 100 million years after the Big Bang. In its short time observing, Webb has delivered more than pretty pictures. It's producing discoveries that force astronomers to rethink long-held theories. Startlingly massive, well-formed galaxies appear in the very early universe. Models predicted small, irregular first galaxies that grew slowly. Webb instead finds surprisingly large, mature systems just 300 to 500 million years after the Big Bang. Another breakthrough: exoplanet atmospheres via spectroscopy during transits. Confirmed: water vapor in a gas giant's atmosphere. First clear detection. Carbon dioxide on an exoplanet. Crucial steps toward finding planets with conditions for life. Webb maps complex organic molecules in star-forming regions, the raw ingredients for planets and potentially life. It also reveals our backyard: Jupiter's faint rings, tiny moons, giant storms, and auroras at the poles. Plus, icy moons and distant Kuiper belt objects. Webb is rewriting the astronomy textbooks. Webb has not made Hubble obsolete. It's given its older sibling a powerful new partner. Science isn't a competition, it's collaboration. Hubble is our sharp eye for the visible universe. Webb is our sense of heat, feeling hidden stars and ancient stretched-out light. Together, one sees structure, the other sees energy, the present and the past, both essential. Webb is designed for at least a decade. With careful fuel, it could last 20 years or more. Soon, the Nancy Grace Roman Space Telescope and giant ground-based observatories will join the quest. Each new instrument adds a piece to the grand cosmic puzzle. For centuries, humans looked up and wondered. Hubble showed us unimaginable beauty. Now James Webb takes us deeper, back toward the first light itself. What will we discover next? Only time will tell. But one thing is certain: the universe is far more mysterious than we ever dreamed. Do you think Webb will find signs of life? Comment below. If you enjoyed this journey, subscribe for more.